All right, welcome everybody to Context Engineering for Agents and Multi-Agent Systems, presented by Dr. Greg, that's me, and The Wiz, that's my counterpart and CTO here at AI Makerspace. You know, AI Makerspace was born out of me spending about 10 years as a university professor, and I saw that the only people that were succeeding in a 21st century workforce were those that were learning new skills, using those new skills to build awesome things, and then sharing the awesome things they built with others. It wasn't degrees, it wasn't prestige, it wasn't pedigree, it was making things as part of a community. You're here with us. That means we're going to ask you to join us on our mission to create the world's leading community for people like you who want to build, ship, and share production LLM applications. You're going to see a concepts and code approach from me and The Wiz today that really focuses in on our core values as a company. That is very practical AI education. This is highly technical, but highly practical. We are focused on delivering ROI for you and your company. Building, shipping, and sharing from concepts to code is the secret sauce. We try to make it easy for you so you can make it easy for everyone in your network. By embracing a give-first mentality, we can all embrace the LLM edge and focus on what we don't yet know, which is always more important than what we already know in the age of AI. All right, so we got a real lightning lesson for you today. This is a big topic, and we're going to cover it all. If it doesn't make sense to you, we got tons of resources to go deeper, but today we want to answer the question, what is an agent? We want to understand this in context of the foundational, fundamental patterns of agentic behavior. We want to also understand where we're at in September 2025 in terms of context engineering for agents and multi-agent systems. We're going to use the Agents SDK from OpenAI to build, ship, and share a multi-agent calendar research assistant. Let's get into it, everybody. We're going to start with agent definitions. We're going to move through a number of ways to view agents that allow us to think properly about context engineering and the implications of the systems that we build and put into production. Cover what we need to know about the Agents SDK, and then Wiz will get into the build. If you have questions along the way, please do not hesitate to smash the chat. We've got AI Makerspace folks on deck ready to answer any and all questions that you throw at us. But let's start where we need to ultimately end. If you don't know already, it was Dex Horthy that coined the term context engineering. Everything that makes agents good is context engineering. Let's see if we can make heads or tails of this by the end of today's session. So agents, you may have seen this past week that there are definitions floating around about agents. This is from Simon Willison. He's ready to accept a definition of agents. An LLM agent runs tools in a loop to achieve a goal. This is our very own LLM wizard, Chris the Wiz Alexiak, who will be presenting the code today, chiming in on this. Now, Simon goes on to have a quick discussion about this that we'll come back to with Wiz. I encourage you to dig into the details of this if you're so inclined. This isn't sort of willy-nilly, though. He's been doing this for a long time. This was something put out by Swix and ahead of the AI Engineer Summit in June, trying to sort of crowdsource definitions for agents. There's lots of stuff here, and lots of it's good. He wrote sort of a robust blog on this entire thing. He's been doing this thing where he's trying to figure out the definition of agent, and he finally gets to this similar definition that Anthropic put together in May. Agents are models using tools in a loop. We've done similar investigations ourselves at AI Makerspace over the past months and years. In fact, we looked at every agent framework on our YouTube channel, and we kind of got tired of doing this because we saw the same things over and over. Here's our definition. An agent or agentic system is a system that can leverage or emulate reasoning to make dynamic decisions in an application flow. Let's break this down. We want to give the LLM access to tools. In doing this, we can enhance the search and retrieval process. We can think of this as kind of a fancier RAG, and we're going to be leveraging fundamentally this reasoning and action pattern. So let's dig into this idea of fancy RAG. Well, the idea of RAG is to avoid the problem of hallucinations. We don't want our LLMs to confidently lie to us, or at least plausibly say false things to us. In fact, we want really good outputs. When a user puts something into our app, we want to provide something that's really great coming out. RAG helps us kind of break this down into two pieces: retrieval and generation. In general, we can tweak and optimize both of these, but in practice, we're typically focused on the retrieval step. As goes retrieval, so goes generation. The agent has access to tools, but RAG is really just about giving the LLM access to specific knowledge that it wasn't trained on. We do this through retrieval plus in-context learning. In brief, we ask a question. We're essentially using embedding representations to go search data really quickly and then return that data into a pre-configured prompt. Using the provided context, answer the user's query. You may not answer the user's query unless there's specific context. If you don't know, say, I don't know. And then we'll return good stuff back to hopefully be fact checkable and avoid hallucinations. We want to say, just say, I don't know, because better than lying is to just abstain, right? We see this all the time in the court of law. So we return the stuff that we need. Now, it's back in natural language. After the vector retrieval process, we put it in context. This is almost RAG, but this is retrieval augmentation. We got to do the final generation piece and get our better answer. So we have the retriever and we have the generator. This is not the point of today's talk, but this will help us understand more about agents and multi-agent systems. RAG is going to allow us to optimize this retrieval step to essentially connect users to information that we know they want to have access to through our application. Now, we can build RAG applications, and in fact, we build RAG applications in our course in LangGraph, starting out as a DAG, even though we use a LangGraph approach. This is because this is the best practice today, and it's quite simple to move this into a more agentic flow. Now, if we just consider this retrieval step, kind of enhancing it with a tool, we can start to see what agents are all about. You see, agents come into play during this retrieval and prompt construction or augmentation step. Agents that have access to tools can help us solve problems, achieve goals, get tasks done. In short, agents are kind of just fancy retrieval augmentation. And so we can see this through their tool usage. Let's talk about that tool usage. We can do lots of things with LLMs, from simple API calls to simple RAG applications. And let's go back to the coiner of the term himself, Dex. My biggest takeaway when I started learning about agents was that you get to throw the DAG away. Oh, okay, that makes sense. So we're in the right place here. Rather than use a DAG, we can let the LLM make decisions in real time to figure out the path that we want to be able to go through to achieve the goal. Now, we could take this to the next level from simple RAG to kind of simple rules in a loop. We can think of this as we kind of are giving the LLM superpowers a bit. It can do reasoning, it can take action with the different tools in the tool belt. And this loop, this agent loop, is what we need to go through. We ask a question, it goes to an agent. It doesn't go to simply a embedding model and vector store like in RAG. Although the actions we take could include just leveraging a RAG tool. Those actions are going to then inform the agent, and we may know the answer at that point. In fact, we may know the answer before even taking an action. Typically, those actions, we think of those things as tools. And we're going to observe some sort of result, some sort of new data from taking those actions, from calling those tools. That's going to be fed back into the conversation thread of the agent. So the big idea here is like these things are just giving us stuff back when we request it. We call the tool, like we've defined the tool, get weather, and then we want to call the tool, get weather of a specific location. Then we want to get a response. This kind of tool calling, aka function calling, is an example of this reasoning action pattern. This pattern outlined in the October 2022 paper React sort of foreshadowed a lot of stuff to come in the land of agents. Reasoning traces help the model induce, track, and update action plans. Actions allow it to interface with and gather additional information from external sources. And so if we kind of look at our little diagram here, we can actually see the reasoning step the LLM is taking. We can see the action step it's taking. Now, this is where our last piece of agents comes in, the reasoning action pattern. You see, this pattern is key because agents are not just a specific thing, they are, in fact, a pattern. And tool calling in a loop is, in fact, a pattern. An LLM agent runs tools in a loop to achieve a goal, as we've seen before. Now, what's interesting is if we zoom in on this discussion that Wiz and Simon were having last week, as for the in a loop bit, that's a shortcut for saying the LLM harness spots the tool call request, executes the tool, and then calls the LLM again with the result of that tool call. So we can kind of see the LLM harness spots the tool call request, executes the tool, and then calls the LLM again. Let's see how that works. Well, this act piece, we're going to kind of spot the tool, we're going to execute the tool, and then we're going to pump the stuff back into the conversation thread, into the context of the agent. So this piece right here actually is pretty cool because if we zoom in on it, where we have the reasoning and the call happening kind of right here, this is what we actually call function calling. This is where we're combining reasoning and action into a single step. So giving the LLM access to tools is just literally giving the LLM access to functions it can call. And this is not new technology. I mean, the OpenAI function calling API was released in June 2023. These models have been fine-tuned to both detect when a function needs to be called and to respond with JSON that adheres to the function signature. So we can see this in something we've already seen before, right? Tool calling, tool, call it, get the response. Well, if we zoom in here, we can also see we need to execute the function code. So these are not different things, they're the same thing. And we want to go ahead and note that the tool and the function are kind of the same thing. Which brings us to context engineering. And back to our definition of agents. It's a system that can leverage reasoning to make dynamic decisions in an application flow. It's giving the LLM access to tools, it's enhancing search and retrieval, it's the reasoning action pattern, it's going beyond DAGs, it's going beyond RAGs as DAGs, which is simply giving the LLM access to new knowledge that we have basically in our coffers. And it's going beyond prompt engineering too, which we didn't talk much about, but this is just literally giving the LLM instructions in context. As we've seen, context engineering has kind of subsumed prompt engineering. And context engineering includes all of prompt engineering, as well as state and short-term memory, structured outputs, RAG, lots of stuff, including tools. Now, is agents within the context engineering bubble, or is context engineering within the agents bubble? Let's stay away from that discussion for today. The point here is that if we fill the context window with just the right information at exactly the next step, then we're doing the number one job that AI engineers should be doing. We're doing the stuff that makes agents good. We're doing the stuff that manages what we're putting into the context window, the conversation, as it increases. Because as agents engage in this kind of conversation, it can grow hugely, massively. And it requires very, very careful context management strategies, from pruning to augmentation to all sorts of interesting things. Now, we've only talked about single agents so far, so it's worth extending this for the purposes of today's discussion. If we think about the AI makerspace definition of an agent, it's a system that can leverage reasoning to make dynamic decisions in an application flow. We might ask, before we build an agent, do I really need this dynamic reasoning to solve the task or the goal or the problem more effectively than a rigid workflow could, more effectively than a DAG could? In other words, do I have too many if, else things going on? This extends directly to the idea of multi-agent systems, where we might say it's a system that can leverage reasoning from multiple independent agents to make dynamic decisions in an application flow. What should we ask before we build a multi-agent system? Do I really need several specialized dynamic reasoning machines collaborating to solve the task or goal or problem more effectively than a single agent could? In other words, after I have one agent, do I still have too many if, else statements? Now, these systems can be really good to sort of separate out groups of tools, different responsibilities, different prompts, different context windows, as we'll see. Separating these functions, separating these tools, this is very important. And ultimately, these multi-agent systems, they are sort of scaling out test time compute, but we can kind of think of them very simply as tool calling in a loop all the way down, or function calling all the way down. So what are the implications of this? Well, this gets us up to sort of some of the state-of-the-art thinking around this. If agents are often engaging in conversations spanning hundreds of turns, requiring careful context management strategies, what can we learn from some of the sort of canonical context engineering content out there? Well, from the initial talk and GitHub on 12-factor agents, we can learn that if we really own our prompts and own our context window, we can kind of optimize through minimizing context utilization. This isn't like GPUs. We don't want to maximize the utilization here. We want to actually minimize the context that we need. This flies in huge opposition to long context windows are the answer. RAG is dead, long context is the king. This goes on to sort of be sort of magnified by other work that's been done. Reliability itself might come from great context management. There's the idea of like agent engineering. And we even see in some of the leading papers that are coming out and being noticed now, like this one called Design Patterns for Securing LLM Agents, is that if we minimize what we're putting in context, that is one strategy to protect against prompt injections. Like, it's not the only way, of course, but it is one way. That is, it's harder to attack when there's less surface area to attack within your context. And, there's also this idea of context rot that was put out by Chroma officially 2 months ago. Longer is not better. They're showing performance can really degrade as we shove in more and more tokens. And so we can see this kind of idea that context, this is from the team at Manus, it's not like it's a one-shot thing. It's like as the multi-agent systems are operating, context is becoming longer. So we need to reinforce context, not just assume we can rely on shorter long-term memory. We need to use few-shot prompting very sparingly. We need to make sure it's adding value. And we want to kind of leverage a prompt structure that is directly impacting and increasing speed, minimizing cost. Context becomes long over time. And so we're forced to do something about it because it becomes a long context problem when we operate our application. So altogether, we might say we really need to own and minimize context in order to optimize it. We've got to actively manage that context over time. And, I mean, in the end, we're talking about you put garbage in the context window, you get garbage out. I mean, it's not that hard. And in fact, too much garbage is actually kind of unsafe. It's like super trash. And so we're going to build something today with all of this in mind. And then we're going to talk about, in our specific context, how might we think about applying some of these principles. To prepare for our code build today, we're going to talk about the bare minimum we need to with the Agents software development kit. This is from OpenAI, and this is from March 11th that this came out. So relatively new, and they had experimented with Swarm before. They wanted to make enough features with few enough primitives that work right out of the box. Let's see if they did it. And it works pretty good, and we'll see a number of things that are starting to look familiar to us now. Agent loop function tools. Well, we've got this idea of handoffs we've got to tackle. But few enough primitives, basically, to learn. And we need to basically just understand two things, agents and handoffs. There's also this idea of guardrails. That's beyond the scope of today's talk. Although, certainly when we work with enterprises, they ask things like, when should I actually be leveraging guardrails? And that is a bit of a context management question as well. But an agent in the OpenAI Agents SDK is just a list of instructions along with the tools. Look at that. Seems pretty straightforward. And a handoff is an agent handing off a conversation to another agent. Also very straightforward, which makes sense because once an agent expresses the intent to make a handoff, it reasons through that it needs to make a handoff, it is time to take action to make it happen. After the reasoning, we take the action. And so we see this combination of reasoning and action into single steps all the way down on these systems. So we're going to build a multi-agent calendar research assistant today. And this one's going to basically have a number of agents, a calendar agent. We're even going to have an MCP setup here for those of you guys looking for some MCP goodness. Event analyzer, a research agent, a preparation guide agent, and then an orchestrator. And we're going to sort of talk through this, and Wiz is going to walk through this with context engineering in mind. And with that, we're going to head over to the Wiz for today's demo.
Yeah, that's right. Okay, so we're going to talk about the build today. The build is pretty straightforward. The idea is that we just want to build an application, and we want to explore where in the application we're having considerations for context engineering. And so we're going to do this in the kind of, repo that should be shared in the chat. It's very simple. We're just going to do a little bit of, OpenAI Agents SDK to kind of look through the lens of context engineering. There's loads of text, so there's lots of Markdown. If you're in a Markdown, you can read that at your own leisure. We're just going to kind of focus on the actual code pieces. For this example, we're going to use a connector from OpenAI Agents SDK, which is the MCP server for Google Calendar. So this is going to have access to our calendar, and that's about it. We're going to get all of our required imports out of the way. There's tons, classic. A lot of it, though, is Pydantic, agents, and OpenAI stuff, so all good. The next thing we're going to do is think about our structured output models. So this is something that's pretty important to the flow here, right? Instead of just having random stuff returned to us, we want to have this kind of very focused, specific information returned to us. And that's why we use something like these Pydantic models to populate, exactly what we need so we can pass that to the next step of our application. We don't want to just retain tons of text, right? This is especially relevant when we have models that just love churning out tokens, right? So reasoning models produce high volumes of tokens. Almost all of those tokens are totally useless to our application, right? They're incredibly important to the model for coming up with a great final answer, but they're not useful to our application. So this is one of the things that we have to manage, right? Where do we put all of that extra stuff we just don't care about? And these kinds of base models help us to do that. So you'll see we have a bunch. We've got one for our calendar events, for our research topics, for our event research, for our preparation item, and for our preparation guide. So the overall view of this agent is that it's going to help us prepare, for an event that is on our calendars. That's the idea. So also, you don't have to use Pydantic here. You can use just JSON mode and parse it out however you want. We're using Pydantic because it works well. Then we're going to create our actual first agent, which is going to be our calendar agent. This is what this is the artist formerly known as prompt engineering, right? Where it's been up leveled to be part of context engineering, though. The idea is that we haven't left just because we're calling context engineering something else, or we've made sure to include prompt engineering under the umbrella of context engineering. Doesn't mean that your prompts don't matter anymore. They still matter a lot. You're still going to spend a lot of time engineering good prompts. You don't have to, go nuclear and start with something like DSPy, but certainly that is an effective way to do things if you want. We're just going to stick with writing very specific instructions for each of our agents. And then, of course, we have our event analyzer. Again, we're seeing just hyper-specific instructions here. Bing, bang, boom, there you go. Finally, we have our research agent. Our research agent is going to work very similar to our other agents, very specific instructions. And we're also going to make sure that it uses the tool, right? So we know that we want information from the web. We know we don't want just the model's response, right? That's not going to be something that's acceptable to us. And so as part of making sure the right context is in the right spot, we want to make sure that we definitely use this tool to fetch information. So this is something that's not unique to the way that you've been building applications, I hope, to this point, which is that you have to deeply consider what bits of context get into our application when, right? Very important. Okay. Next, we have the preparation guide agent. Same stuff, same lessons. We'll scroll past it. And then we have the orchestrator. The orchestrator is going to be a class that helps us to, well, orchestrate everything together. Remember that while we have a bunch of different agents, right, they don't share context, but we need to pass information between them. Now, one of the things that you have to consider for multi-agent systems is that if every agent's full context, right, is cobbled together. So if I have like an orchestrator agent and it's seeing everything, all of the noise from all of the different agents, that is going to very quickly lead to this idea of context rot, right? We're going to have tons of unnecessary tokens that we're distracting our LLM from its goal with. And that's why we're passing these very specific packages of information between these agents. We don't want to be in a world where we just say, here's the whole conversation history, everything that's happened, right? That's not going to lead to an application that continues to work well after one or even two turns of conversation. So it's really important that you're constantly kind of paring down the context that you're passing to the next step of your application. If it isn't critical to the functioning of the next agent should never see it, right? If there's hemming and hawing that gets us to the correct decision from one agent, we should not forward that hemming and hawing to distract the next agent. So this is a really easy pattern to implement, right? We just want to be very careful about what we show to the next agent and how it interacts with other agents of its kind. There you go. Then we have our, the actual running and passing is easy. It's just some Python, right? We have some tasks. We execute our tasks in an asynchronous fashion so we can collect them. And then we write our summary using beautiful print statements. And you'll notice as well, whenever we're thinking about, performing research, for instance, right? We are not, again, pasting the whole blob from the previous interaction, right? We are in fact pasting just the bits that are necessary. It's the same everywhere. A final thing to consider when you're working with multiple agents, right, is that we might have many processes running at the same time, and we might need to collate a lot of different things back together. And in situations like this, it's even more important that we reduce distractors, right? So we just want the final outcome. Like when you're working with your, not to over anthropomorphize, okay, but I will just for a moment. When you're working with your colleagues, right, you don't tell them, hey, this is everything I thought about while I made this decision, right? Here's my absolute thought process, right? First of all, no one's gonna want to read it. LLMs though, they don't have the choice. They don't have the ability to choose. They just have to read all of it, right? And so we want to alleviate the cognitive load on our poor LLMs by making sure we pass only the critical details to the next step. So now what we're going to do is see it work. So we have our orchestrator, we set it up, we prepare some date. This is going to be today's date. And then we run our preparation. We prepare for data. If there's no results, we say there's no events to prepare. If there is results, we build a preparation guide for each of those events. So I ran this today, and oh, lo and behold, we have an event today. It's called Maven Lightning Lesson Context Engineering for Agents and Multi-Agent Systems. We're in this event right now. It's Eventception. But the idea is that it's able to give me a summary of what this event is about, as well as how things that I should think about and how to prepare for this event, and what we may talk about. Now, one thing that it asks me to prepare, but is not relevant because we're looking at this non-RAG agent solution, is things like different chunking strategies and et cetera, et cetera, et cetera. So I think this is the idea, with when we're dealing with more traditional RAG systems, right, which are, so dense vector retrieval based RAG systems. We don't want to live like you may think to yourself, well, we have models that have infinite context now, or almost infinite context, right? Or very big context. So why would we care about only providing necessary information when we could dump the whole book in and ask questions? Well, the reality is that almost all of the information that isn't exactly related to your query is useless and or literally harmful to the response, right? It's actually just distracting. It's removing some of the effectiveness of our grounding through RAG. And so the idea is we want to provide classic. If you're used to working in an enterprise or in large organizations, we want to provide as much as is needed and as little as possible to our LLMs, right? That's it. Also, we kind of skip past it, but there's some MCPing happening here. MCP is another way that we can effectively manage context. It allows us to understand what tools are available and then also how to use those tools. Someone asks, why not just use A to A? You totally can use A to A, right? A to A is an effective protocol for stringing multiple different agents together. In this case, though, we're all in the same environment, and so we don't really need A to A because we don't expect for these agents to work independently of each other. There you go. And then finally, we can research events for a specific time. So tomorrow, I've got a yap about Nemotron Nano 9B V2 model, and so that comes up with this, and that's it. That's the whole thing. So the big things to focus on is context engineering for agents, multi-agents is not new to what you've been doing, right? It's just it's a more structured way to think about what you've hopefully already been doing, which is We really want to just make sure we're only providing exactly what is strictly necessary to get the job done to any individual component of our stack. We do not want to spend time having fluff injected, right? This extraneous, factoids, knowledge, and tokens that not only we're going to pay for, which is the worst, but also, that we pay for in terms of our reduction in accuracy, which hits us and our users. So that's the code demo. The code's available in the repo that we've linked a few times in the chat. Work through it. OpenAI SDK is dope, and it helps us manage context for up to many, many agents. So there you go. And with that, we'll pass you back to Greg.
All right. Thanks, Wiz. And I think we have one more thing, which is if you like what you're hearing, concepts and code wise, then definitely check out our weekly YouTube live streams. And if you found value in this content, then maybe pass along to somebody else that might find some value in it as well. Wiz, we got some discussion questions here based on your specific context. All right. Do we really, like, you had a bunch of agents in there. Yeah, we could use 8A. Yeah, we could use lots of stuff. But do we really need all of those agents? Like, if I was going to operate this on a daily basis and check my calendar, when would I think about pruning, or when would I even think about doing that before I really start using it based on your user experience so far?
Yeah, I mean, uh, you never need all the context that you just used. I mean, this is kind of like the golden rule. You can kind of always cut context. You can always reduce to a certain extent, of course.
Yeah.
But like you're never at that like information theory minimum amount of tokens, right? Like
The
there's
optimum.
always some
Yeah.
extra. And I think the big thing is like the better your retrieval pipeline is, the fewer pieces of information should be returned on any individual request, right? There should be a very small, very active subset of information that's returned, and you should use every piece of it, right, in an optimal setting. And so, pruning is an extremely important piece of this puzzle.
Yeah, we got some great stuff coming in the chat here. Let's talk about when we would want to do the other thing, which is like, I really don't even have enough context here. Like I need more. Like probably in this use case, you didn't really feel that, but I don't know. Like when would you think about it for this particular use case? What are ways that you might think about enhancing this? This is more of a product question, really, but it connects directly to the context we need to engineer.
Yeah, I would think about it this way: like your pipeline that you use to get good context should be sufficiently complex as to always give you the best context, or some
Mm,
approaching the best
yeah,
context.
approaching
Uh,
the theoretical optimum context. Yeah.
That's right, yeah. Uh, and so in a case like this calendar event thing, right, it may be important to see if there was previous events, and if those previous events had recordings and access to metrics, like what went well, what didn't went well, or what didn't go well, right? So you can always imagine building a system that is more complex, that gives you even better context, right? But the trade-off here is we want to keep things like working and functional. And so for something like code agents, this is a lot simpler, right? Our code agent has very well-defined set of things that it must have access to. It must know the structure of the code. It must know the libraries you're working with, and it must have some idea of what environment things will be run in eventually,
Mm.
right? But for things like calendar events, it can be a little bit. It
Yeah,
can be a
like,
little
and it
bit.
knows what code was just executed,
Yeah.
right? And like, that's probably pretty relevant,
And what are our like performance, requirements, and what are our, accuracy requirements? All
Mm.
these things. This is all excellent context, right? And so enhancing the pipeline looks a lot like making sure only that very necessary set of information gets in, and we block everything else. We put blinders on to every other piece of information in the universe. We only care deeply about the things that move the needle on our application.
Okay, yeah, but let's talk about the most important thing, or I should say, the most important thing that people are talking about today. Evals. We didn't even talk about evals, bro. Where are our evals on this app? How come you didn't put any on? I mean, what should they be here exactly?
Uh, Evals are interesting because
I mean, did they pass the vibe check? Let's start there.
yeah, I mean it passes the vibe check for sure.
Sniff
Evals are
test, it's good. Yeah.
yeah, yeah.
Okay.
Evals are the most interesting and important piece of the puzzle, and yet to spend to spend time on it now
Yeah.
is a distractor or
Yeah.
distraction.
Yeah.
But in reality, like the amount of evals that you need for something like context engineering race, how much of your context was useful to the final product, right? How much of all of the tokens did your LLM see?
Meta context engineering is
Yeah,
the eval.
you
Yeah.
know,
Love that.
that's what I would say.
Okay. Yeah. I mean, there's a lot of things that you could slap on here, post vibe check. You could write up all these
That's right.
things. LLM, do you like the calendar thing? And it's like, well, it's like maybe we need a virtual whiz and he's evaluating. So that's a rabbit hole, but I figured it's worth mentioning here because, good or bad, great or correct, all these things are important to consider. This is obviously a very low, it's a low risk application. And so, do we really need to be super robust with that, or are you happy with how it helps you prepare for your event tomorrow? And maybe that's good enough. So, okay. Then we've got a couple of great questions in the chat. I just want to wrap for today here, guys. We'll keep Wiz up here for QA. Agents are patterns, not things. We covered a number of definitions, ways to think about them. Multi-agents, we can extend that idea. Do you really need several dynamic reasoning machines? Well, maybe, maybe not. You should ask these questions. You can use OpenAI Agents SDK. You can use all the other open source agent frameworks. We've covered them all on our YouTube channel. And you learned how to build, ship, and share a multi-agent calendar research assistant. So let's talk about a couple questions in the chat here. Let's see. Like, why do we need separate agents? This is from Deshant. Can't we just provide context to the same LLM and then provide different context to the same LLM to sort of simulate different agents? This is a very interesting question.
Yeah, I mean, uh, it's kind of like this double-edged sword, right? Where this is also in some sense context engineering, right? Where like if we have these once we enter this kind of next level world, we're now having to construct systems that are even more complex, right? And so it's yeah, it's just a very
I mean, and if you do that, is it a single agent system then? Or is it actually a multi-agent system?
I
I
mean, it's
mean,
all
it's like,
multi-agent. Once you have
yeah.
multi-agents, it's dumb to to say it because everyone already knows. But
If you
like,
talk to one agent twice, is that two agents? I mean, it's like, yeah.
no. Let's hope not. Let's hope
Okay.
not. Let's
Well,
hope
some
not.
long-term memory, definitely not. I mean, yeah, okay. There's a lot of interesting ways to fall down the weeds here.
Yeah.
I don't see any other amazing questions here. Lots of metrics, indeed. Lots of evals, lots of tracing, lots of stuff we should look at. Definitely lots of ways to optimize this system. Context.
I got my favorite question.
Yeah, yeah. What is it?
How will we know if we need multi-agent systems versus single agents? A
Such a good
classic.
question. Yeah.
And the answer is if you build an application and you find that one agent is not doing enough or not doing well enough, you
Doesn't
should
have enough
then build
agency.
more agents. But the
Yeah.
reality is, the moment you can envision separation of tasks, right? The moment you can construct a system in a way that allows you to separate out tasks so that each agent is very focused on a particular task, right? That's a great time to introduce multi-agents. Now, there's some back and forth in the community about code agents. Do code agents require multi-agent solutions? Devin and Claude Code, right, have kind of duked it out on this a little bit. And the answer is if you can have very atomic agents then you should build very atomic agents, because the likelihood is down the road you're going to want to compose those different atomic agents into different kinds of systems
Mm.
based on, you know, the new needs as they evolve. This is
Oh.
this is the beautiful thing, right? When you're working at a company, again, we're just going to over anthropomorphize for a
Yeah,
moment.
yeah, let's go.
When
Let's
you're
go.
working at a company, you start off with job A, and then slowly you acquire more duties until you evolve into job B, and you've
The
got
classic.
people helping you below you in the org chart doing job, you know, A now. And same thing for agents, right? If we allow each agent to specialize, then we can compose beautiful little teams of them together as
Mm.
the use case evolves.
That's
As
right. And just as we saw prompt engineering start with simple in, simple out, and then we saw it kind of expand and move up a level, and then now it matters what are the prompts on the tools and what are the prompts for the agents and what are the now we're sort of getting into this. Actually, there's a broader context idea. There's this agent engineering idea. And as agent engineering folds into sort of multi-agent engineering and then team agent engineering and all this, this is sort of the way, and we can go back again to what the best practices that are appearing to be emerging are, which is keep your context lean, minimize what's in a context window. Well, what's the easiest way to do that? I mean, split up the tasks, split up the stuff you have in context that could be split up. So yeah, interestingly, maybe if the agent has enough stuff in context, you know, what's that magic context number, like 7 friends on Facebook or whatever? Multi-agents, look at it, do it. I'm sure we'll come to that soon enough. Dino wants another one on evals. Maybe we can. Let's go ahead. Sharang, drop some links. All right, you got it, Sharang. Drop some links. I'd love to get into the chats here, and we'll keep these lightning lessons coming, guys. Thanks for joining us for today. Wiz, thank you for your insights. And again, thank you for joining us for another AI Makerspace lightning session, where we are on a path and on a mission to create the world's leading community for people like you. If you're still here, you don't hate code, who want to build, ship, and share production LLM applications. And if you haven't joined our Discord yet, we've got tons of cool, competent folks in there. You'll meet Laura the legend as soon as you get in there. You've probably seen her in the chat today. We're almost at 3,000 people in the Discord. It's popping off. We'd love to see you every week on YouTube. And you will be automatically subscribed to the LLM Edge for attending this session. So thank you for that. This is basically going to break down everything that we talk about on a week-to-week basis. Follow Wiz on X for sure. I'll do my best to get in. We just launched another course that I'm going to be teaching with Kat, aka Kat GPT, on more beginner style. So if this was very overwhelming for you, this might be a good way to get started. However, our flagship AI Engineering Bootcamp is always running, and this is for the more advanced coders and software engineers among you looking to really get after it and go all in on AI. If you've got a team that we can help out, hit us up and let us know. Otherwise, until next time, keep building, shipping, and sharing, and we'll do the same. Thanks for joining us, everybody. Have an amazing night, and we'll see you all again real soon. Let's roll out. Bye, guys. Cheers, everybody. See you soon. Thanks, guys. Later, Manny. Good to see you, Michelle, Dino, everybody. Thanks, Sharang. Bye, guys.